Hi, I'm Gabriel Cuomo, and I'm very happy to receive the CHIPP Prize for my PhD work. It's an honor, it's incredible to be selected among so many excellent students here in Switzerland. So I am now in Zurich, and I often am in Zurich because personal connection. So my girlfriend, she's been doing her doctoral studies here at ETH since a few years. So since I was PhD student in Lausanne, I was often traveling here, and now from the US, I'm taking the plane whenever I can to spend some time here with her. Yeah, so I was born in Sicily, in Catania, in 1993, and yeah, that was definitely where I did my bachelor studies in Catania. Then I moved to North Italy and eventually to Switzerland for my PhD with Riccardo Rattazzi. That was so far the most important stage of my career. It really cannot be overstated the importance of this PhD for me. And now I finally started the third stage of my career in the US for my postdoc in Stony Brook. I moved there because now I'm working at the Simons Center for Geometry and Physics, a center funded by the Simons Foundation, which is one of the most prestigious ones in the world nowadays, and it has a unique connection between geometry, as the title says, so mathematics, and theoretical physics that I can benefit a lot from. My current research group is made of many young people. Also the professors are relatively very young, 35, 40 years old. So life as a postdoc and researcher in the US is different than I would say in Europe. There is perhaps a bit more pressure and there is a lot more of excitement about whatever you're doing. In Europe, people are more conservative and try to, always say, we are not sure whether what we're doing will be the best or whatever. In the US, everything's going to be the best. So you got to learn to relate yourself with this attitude. And when you present your work, you got to be very self-confident. So it's something I'm slowly learning by working there. So the main goal of my research overall is understanding quantum field theory. So quantum field theory is nowadays understood as the language of physics at many levels. It could be statistical physics, condensed matter physics, and most importantly, particle physics. My goal is understanding general properties of quantum field theory from a mathematical perspective. So in simple words, we can think of every model we have in physics, like a model describing some phenomenon we want to observe or some mechanical movement as a book. And then we want to understand the language in which the book is written in general. Quantum field theory is a bit like the general language in which many books or many phenomena can be described within. On the one hand, I've always been passionate about science and also about math, so theoretical physics combine them both. But perhaps at a more fundamental level, I think in physics often you're concerned with how, you want to make an experiment, you want to make it work, or how this works. In theoretical physics, sometimes you also ask why, and I think that's what I mean. You don't want just to understand how something works, but why it works that way, at least to the extent that can be answered within science. So that's what I really like about theoretical physics.